Welcome to part 9 and the final video of this mini-series about project risk, and I'm going to talk now about quantitative risk analysis methods. I'm going to describe them very briefly because what is a quantitative risk analysis? Basically, when we use, this is used for high risks in order to better understand them. So in other words, because this gives so much more work, it's only worth it to do for high risks. And here what we try to do is we identify how a product or a process can fail, for example. We call this technique over here that you see now on the slide, we call the FMEA. And this is a table that normally is used it's used for a project, for product development, and well, for other projects can also be adapted. But here is to try to estimate the risk of a specific cause resulting on a product or process failure. So for example, if I have my project and I'm going to try to determine what are all the things that could happen, or what are all the parts or all the process steps that I have, and what could be the potential failure of this part or of this process. And then I try to analyze the effect of the failure, the cause of the failure, and the process control that I can have. And then the little columns that you see there, severity, probability, detention, then what we try to do, for example, is give them a score from 1 to 5, with low being a very low risk and high being a very high, well, a very high number. For example, severity, 1 is very low impact, 5 is a very high impact. Probability, 1 very low probability, 5 very high probability. And finally, process control is how well can I manage the process to actually prevent or to actually avoid something from happening. And here again, a 5 I would give in case I know that I have a very high control. And then basically, I would give a 1 for projects that I know that I cannot control, that I can control very well, and a 5 for projects that I know that I cannot control at all. So then I add all of them, okay, for example, and then I would get a score. And then here I'm analyzing all my risks in terms of priority, because the higher the number, the higher the impact that this risk would have. And then I develop finally my action plan. Another one to have is, for example, a decision tree. Now, decision trees are very useful, but only when we have the data. As an example, I found this example online and I think it's very good. This is a statistical technique that calculates the average outcome when the future includes scenarios that may or may not happen. So as an example here, we have an option for a factory. And that option is, should I build a new factory or should I upgrade my current factory? Well, if I build my new factory, so we're here now, if I build my new factory, the investment is $120 million. And from this investment, there's a 60% probability that I would have strong demand profit. So I would make a profit of 200 million. There's a 40% probability that I would have weak demand and only generate 90 million. So for each one of them, then I calculate what would be my profit. So my profit on this point over here, on the first one, would be 80 million, while my profit on the second one is just negative 30 million, so I'd have a loss. Now, going back and into the upgrades to the plant, to upgrade the plant, it would only cost 50 million compared to 120, all right? And there's a 60% chance of strong demand, which allow me to get 120 million in terms of profit. And there's a 40% chance of low demand, which allow me to get 60 million profit. So from this I see, in the condition of upgrading my old plants, and if I get a strong demand, then I'll get 70 millions in terms of profit. If I get weak demand, I get 10 million of profit. Then what we do is we calculate the expected return on this investment, the expected value that I would get. So what I do for each one of them is we calculate the probability of it happening. So in this case, for the first one was 60% times 80 million, and I got 48 million. The second one, 40% times negative 30, and I get negative 12. And I do the remaining one for the other two. Okay, so probability times the profit. And then what we do is we add the ones that are related. So I'm going to add the ones related to the building path, 48 plus negative 12, which would basically mean 36 million. And then I have here 42 plus 4 million, which would give me 46 million. Oops. So actually what we see here is that the best path, or the one that has the highest probability of success, is actually the upgrade path, because it has the probability of generating me the highest amount of profit or the highest amount of return on my investment. So this is the other technique we can use is simulation. Simulations are great. They're normally computer models that are used to project the entire project or to project modeling situations. And if you use, for example, a software management, project management software, for example, like Project Libre, this is what you're doing. You're doing simulations because you're trying to predict how the project will go and you're using a computer for it. So you can use it to do simulations in terms, for example, of time. You can do simulations in terms of budget. But I just want you to realize that just planning the tools that I mentioned, like Project Libre, this is one thing, but you can do many more different types of simulation. So as you see, quantitative risk analysis methods is another great way to help us understand and measure the impact of risks. It can also help us understand what is the best solution or what is the best path to take when managing a risk, positive or negative. They're a little bit more complicated to do, but overall, I believe that they can give very useful results to help us manage our risks. Thank you very much for watching this mini series. Let me know if you have any questions on the comment section below, and I'll see you on a future video.